So topic is build a function from existing functions. So what this thing is going to lead us to is to have an example of a function, and then how we can have at least two functions, how we can use those two functions to create another function. You see, is that not what building is all about? You use some things to create another. So in your book, this kind of topic, they described it as combination of functions. You can build a function by adding, by subtracting, by multiplying, and by dividing. Just like you deal with regular real numbers. Just like you deal with regular real numbers, you can also deal with function in that manner. Okay? So now let's start with some practical examples of situations. In this case, instead of just using real numbers, we will just use functions to represent the situations we are going to start with right now. So if I have a line, just a line segment, you may call it a line segment from point A to point B. And then I have another line segment from point C to point D. If this line segment is represented by something like x plus 2, and this one probably something like x squared plus 2x plus 3, something like that. So both of these things are functions. Both of them are functions. So you can represent the first one as f of x, and then you can represent the second one as g of x. Bottom line is, if you want to combine these two functions, you can combine it by way of addition. You can combine it by way of subtraction. You can also combine it by way of division. Does that make sense? And whatever you get is another function by itself. Whatever you get is another function by itself. So what that tells us is there are different ways we can build a function. We can build a function from an existing function by way of number one, by way of sum, by way of difference, by way of product, and by way of quotient. Okay? So all these things are just big words. Sum is just add. Difference is just subtract. Product is just multiply. Quotient is just divide. So don't worry about all those big grammar, but use them nonetheless. Okay? So now, considering those two functions we have right now, we can do sum. So which means somebody can say, what is the total length from A to B, D rather. Total length from A to D, considering what we just have right now. Total length from A. So all that person is asking you to do is add f of sum of, sorry, let me put it this way. So if somebody asks you, what is the total length of the line segment? So let me write that question. What is the total length? This is length of the two line segments. So all that person is asking you to do is solution. The person wants you to do f of x plus f of g of x, f of x plus g of x. Or you can write this as, another way you can write this would be f minus g x. That's another way you can write it. So this thing is telling us what to do. This thing is telling us you can write it both ways, bottom line. So now, in order for us to implement that, we are just going to say, and once you do the addition, whatever you get is going to be another function. So just decide the name you want to give the next function. So since it is total length, you can call it L of x. L of x would be equal to, so the first length is x plus 2, then plus what? X squared plus 2x plus 3. Okay, so in that case, if you just open up the parentheses and collect like terms, if you open the parentheses and collect like terms, so what are we going to get? I need volunteer, please. Open the parentheses and collect like terms.
X
Yeah, go ahead.
squared. Wait, do I give you the answer or the like
Yes,
terms?
go ahead. Yes, x squared, go ahead.
Plus 3x,
Yeah, plus 3x, which is plus,
which is
hold
x
on, plus
plus
x
2x,
plus 2x. Yeah, go ahead.
plus
Plus
3 plus 2,
plus
or
3
plus 5.
plus 2. Okay, so this is collecting like terms. And then just make sure you collect the like terms correctly. So you are going to have x squared plus 3x plus 5. This will be the length of the line segment.